Hi, this is Mr. Beck does your homework. This is homework number 12 on Springs and Hooke's Law, question number 8. It says, from your experience with springs in lab, you learned something about the relationship between the extension of a spring scale and the weight hung from it. Assume you observed for a certain spring that it stretched a distance of 1.9 centimeters when you hung a weight of 2.7 newtons from it. Well, wait, let's hold on for a second. The 1.9 centimeters is going to be the distance, we'll call that x1, equals 1.9 centimeters. When you hung a weight of 2.7 newtons, well, that's going to be force 1 is 2.7 newtons. I'm just keeping track of these things, not meters, of course, newtons. Then it goes on to say, when you hung a 4.05 Newton weight from it, it stretched a total of 2.85 centimeters. So now I have a new stretch of 2.85 centimeters, and I've got a new force of 4.05 newtons. It says, using this information, determine the weight of an object. So I'm looking for some new force that would cause a 4.5 centimeter displacement when hung from this spring balance. So I've got a new displacement of 4.5 centimeters when I have this new force that I'm looking for. Now, I really don't need all of these values because when you have a spring, you're going to have the force in the spring, which is going to be equal to this F1, F2, F3, equal to some spring constant times the amount the spring was stretched. Now, what we could do is we could figure out the spring constant for each combination of force 1 or force 2, but what we should find is that the ratio of those is going to be the same. So the spring constant should be the same for a spring, and it should be the force in the spring divided by the distance it stretched, but that should be a constant for any particular spring, or in this case, a spring scale. So I could actually take either one of those and get the force in the spring divided by x, get the spring constant, and then apply Fs equals Kx for this final thing, taking the spring constant from either the first or the second situation and plugging it in here for the spring constant with 4.5 centimeters. But you see also that if the spring constant is the same, then what I could do is I could have that, say, K1 equals K3. So I would have the force in the spring 1 over x1 equals the force in the spring 3 divided by x3. So here's x3. This is the force in the spring 3 that I'm looking for. And F1 is 2.7 newtons. So let's plug that in here. And then the 1.9 centimeters, plug that in here. Then what I'm left with, if I plug the 4.5 centimeters in for the denominator, I could solve for Fs3. So what I would get is 2.7 newtons divided by 1.9 centimeters equals the force in the spring that I'm looking for divided by 4.5 centimeters. And that would let you solve for the force in your spring that would allow it to stretch the 4.5 centimeters. So we're going with the concept that the spring constant is constant for the spring, and these numbers will work out that way. If you worked it out with the second one instead of the first one, you should wind up with the same spring constant.